Hi everyone, my name is Jeff, a member of the Teen Advisory Board for Howard County, and today I'm going to talk about Numpy, one of Python's most well-known libraries. I'm also going to describe and explain what Numpy is, some practical applications of Numpy, how to set everything up, and some key library functionality. Numpy is a data science library, which means that it provides mathematical and logical functions to work with its data structures. And it supports a number of data structures, namely arrays and matrices. Other libraries such as pandas and matplotlib build on Numpy knowledge, which means that you have to know Numpy in order to use these libraries to their full potential in a variety of applications. Speaking of applications, Numpy allows you to process data sets of the same data types and perform scientific computations, as well as create histograms, scatter plots, line graphs, and charts. So how would I gain access to this bountiful store of code? Well, it's actually really simple. In a new and clean file, type import numpy to gain access to all of the functionality. Now onto the array. The array is a data structure much like a list because it stores elements at indexes starting at 0 and ending at the number of elements in the list minus 1. To create an array, you need to call the array function and call it on NP. Then specify the elements in square brackets. These elements need to be separated by commas to indicate that they are separate elements. And they can store objects such as integers, floats, strings, booleans, and other arrays or other objects. To access an element in the array, call the name of the array, then specify the index of the element you're looking for in square brackets beside the name. Numpy provides the functionality to create multidimensional arrays, 1D, 2D, 3D, you name it. And it also provides some variables that represent the information regarding those arrays. Endim returns an integer representing the dimension. Shape returns the dimensions of the array. Size returns the number of items in the array. Say, what if you want to use a part of an array? Array slicing is the solution to that problem. To slice an array, you need to specify a starting index of the slice and an ending index of the slice, with an optional step size. When you slice, the program gets the elements starting from starting index and up until the ending index, in increments of step size. For higher dimensions, you need to specify slices for each dimension. What if you want to create an array of consecutive integers in a certain range? Well, arange provides that functionality. It has two parameter orientations, one being a single integer parameter orientation, the other being a two-parameter orientation. The one integer parameter orientation allows you to create an array starting from 0 and ending at the number you specify. So to clarify, it means it will create an array of integers starting from 0 and ending at the number you specify. While the two-parameter function would allow you to create an array of integers in the range you specify, lower to upper. Reshape reformats the array, and just to note, a key note, the sum between the product between the rows and columns parameters has to equal the total number of spaces in the array itself. For example, a 2x2 array can be reshaped into a 4x1. The append function, like the name suggests, adds an object to an existing array. So to use the function, you need to call the append function on NP and specify an existing array as well as the elements that you want to add. Sometimes you need to reshape it to keep it formatted. The sort function sorts an unsorted array in an ascending order, and that's basically it. So now onto the demonstration, where I show you guys how these functions work in a clean Repl.it page. First of all, I need to import Numpy. I wrote import as NP because I don't want to write NumPy all the time when specifying the functions. Say I want to create an array. I'll create a new variable a and set np.array and specify some elements. Say 1, 2, 3, 4. I have the option to print the array itself. See, it prints all the elements, 1, 2, 3, 4. Say I want to find out the number of elements in an array. I'll use size. Like this, it'll print 4 because there are 4 elements. Say I want to find the number of dimensions. I would use ndim. It'll return 1 since this is a one-dimensional array. Say I want to find the shape. I would just use shape. It prints out 4 because this is a one-dimensional array with 4 columns. Say I want to append something to an array. I'll create a new variable b and then invoke append on np. Say I want to append something to array a. Like, for example, 1, 2, 3. Another array containing 1, 2, and 3. Then I can reshape this into a 1x7 array and then print it. It prints that. There are 2 square brackets because after the reshape, it just became a 2-dimensional array with dimensions of 1x7. Say I want to create an array of consecutive integers. I specify a new variable c and call the arange function. Say I want to create an array starting from 0 and ending at 4. I would do arange 5 and then print it. 0, 1, 2, 3, 4. Then say I have an unsorted array. (34, 5, 2, 8). and I want to sort it, I will call the sort function and set it as resort. It would print the sorted array. Now, what if I want to get a part of the array? I'll specify another variable d and set it equal to sort. Say I want to get the second element and everything after it. I'll do 1 and then the last element, which is index 3. I can do that and it would get everything. Five and 2. And that is it. I hope you guys enjoyed the lesson and learned something new, and I encourage you to check out other library tab videos as they are very informative in my opinion. As always, thanks. Bye.